for the prepaid meter that we are concerned with, but we know this is not a prepaid meter. This is, this is a conventional meter. Yeah, because you can see it's got all these digits and stuff like that. It's those type of meters they were using, like the council and even other departments to take note of the amount of electricity that has been used. But the wiring of this meter is the same with the wiring of the prepaid meters, the sub-prepaid meters, most of them. Yeah, a lot of them, you see those sub-prepaid meters, they are written cash power. If you've seen those small ones, which is written cash power, the wiring is still the same. Those prepaid meters, the way they come, they will have a cover somewhere, and behind that cover it's going to show you the wiring, how the mains should go in there and how it should go out. So let's say this is our prepaid meter right here. This is our prepaid meter. We put our prepaid meter here. We say this is the prepaid meter. Let me write here prepaid meter. Cash power. Let's call it the cash power, because most of the common ones, they are called the cash power prepaid meter. So we're gonna take that as our example. Here we know the prepaid meter looks like so. This is a screen where there will be digits that are going to reflect according to how much units is running at that time. Then here we do have the keypad, which looks like so. For example, there is digits like so. Okay, yeah, this is just an example, Then the connections are done right there on this area. So in this area there is four terminals, which is like this one, that, and that. Yeah, so we're gonna take this as the example of our meter that we're dealing with, but we know this is not a prepaid meter, but we'll take that as an example. Yeah, so this meter, it had a cover here. I think we misplaced it somewhere when we were doing some previous training, when I was training some other guys, so I don't know where they put that, but on that cover there is the drawing which shows how you should wire this meter, and those drawings look like this. Those drawings will look like this. It's gonna say when it's there like so, then it's gonna say this one is coming. It will put an arrow like so. This one is going there. Then this is the live, that is the neutral, meaning the mains now it's coming into this prepaid meter from this direction, and then out of this prepaid meter from this direction like so. This is gonna be the L, and this is gonna be the N. So this section here, I'm gonna say let me say this section, let me do this. This section is this section. The cover which comes here when you remove it, when you take it out from this meter, behind the cover there is writings which look like this. Actually, I must draw this properly, not like this. Let me do this situation here. Let me do this, that one there, that one, that one, that one, that one, that one. So that looks like so. So that cover, the cover which comes right here, it looks exactly like this drawing which is here. So this is being represented by that. So then from here we know now how the supply is going to come from here to this prepared meter. Okay, so this supply, we are going to take our live from this 40 amp circuit breaker, single pole, which is going to come from here. Then it will go, okay, let me use red color there so that it doesn't look, you know, confusing when there's a lot of drawings here. Yeah, so that this one is there. Right, let me get this one. So the live is coming from here and it is going there to there. So we've connected the live from this 40 amps straight to this prepared meter like so. Then our neutral is gonna come from this neutral bar. We're just basically gonna move like so. And to there. So we have it from that point. We know now how the power is coming from the main DB to the sub DB, and from the sub DB we'll see what happens now. Okay, so this is sub DB here. I just want to prepared meter, but it's supposed to be sub prepared meter. There is a difference between a sub prepared meter and the main prepared meter. The meter that you see in the main house next to the main distribution board, that one is a main prepared meter. Usually it's gonna be next to the main DB. It's the main prepared meter. That one is got a slight different wiring compared to the sub prepared meter. But I'm not touching on the wiring of the main prepared meter, because in most cases you're not gonna deal with that. Yeah, you know, in most cases you're not gonna deal with that. You will deal with the sub prepared meter. Yeah, especially according to the level of this training that we are doing now. Okay, so all right, so then now let us now draw our sub DB. Our sub DB is gonna be like so. Let us assume this is our sub DB. Sub DB, let me write here and say sub DB. So in the sub DB there as well, we do have circuit breakers that will be arranged in a similar manner to the circuit breakers that are in the main DB. So we do have here as well the main switch, which also gonna be a double pole main switch. So next to the main switch we can have single pole breaker going to the stove, another single pole breaker going to the geyser, and another single pole breaker going to the light. And then we have the earth leakage here. Earth leakage like so. Then we do have these circuit breakers to the socket outlet. Let's assume we only have one circuit breaker going to the socket outlet under the sub DB. Okay, so things to take note here: 40 amp circuit breaker here that is in the main DB, that is supplying the sub DB. This 40 amps, the current rating for this one is gonna be the same with the current rating for this sub DB, this main switch which is in the sub DB. Let's give it 40. It can even be slightly lower than this one. Let's say 35 amps. Yeah, but even the same, it's alright. It's not a problem. You have 40 amps in the main house under the sub DB circuit breaker, and the main switch in the sub DB, you also have the 40 amps. Then the comparison, the combination there, it's okay. All right. Okay. Then from there we have now, we take our supply to the sub DB from this prepared meter. We know from the drawing here that our line going out, it's coming from here, and it's gonna go like so to the live point of that main switch. Let us consider this is our live, our N, and live. And on this also earth leakage, we can have that, and that. This is the ELU. Right. So then we bring our neutral. Our neutral is gonna come from here and to go like so, all the way through there, goes to right there. That's the neutral. Then we now need to bring the earth to that sub DB. So in this sub DB we have this earth terminal. This is the earth terminal. Then we have this neutral bar and another neutral bar. You can also call this as the neutral bar instead of calling it the earth terminal, because on the point of supply, that is where that earth terminal term is mostly used. Yeah, so you can say neutral bar, and the earth bar there. Alright, then we're gonna take our earth from this earth bar from the main switch, which gonna run. Let's take it like so. It's gonna run like that. Comes here and starts going in the same conduit where these other two cables are running. So it's just gonna pass in here. You see that? It's not getting connected to anywhere there. It's just passing. Did you see that? Then it goes to the earth terminal in the sub DB. So from this point, we've managed to bring the supply from the main DB all the way to the sub prepared meter and up to the sub DB. So then the size of these conductors that is coming from the main DB going all the way to the sub DB, the size, it's gonna depend on the size of this breaker which you are using. This one and this one. So like in our case, we are